All right, we're going to look at our last problem that we have today. Uh, Here we're going to find a few of the values. So I'll just kind of write some of these out. I'll say this is I1, say this one's I3, this one is I2, and up here this will be I4. Okay, so just four current directions. And actually we'll drop a fifth one here, I5. All right, and we're just going to find uh, all of the node voltages and all the currents that run throughout the circuit. So let me go name a couple of these. This will be V of A. This one here will be V of B. And then this one here will be V of C. All right. So we've got to find 8 values. Sounds terrible, right? It might be, but we're going to do it together. So looking at this circuit, you've got a couple options. You can either do a mesh loop, which would involve you doing a system of equations, or you can do a nodal analysis. So I'm going to do a nodal analysis just to get some more practice in with everyone. Okay, so doing this, let's go ahead and pick a point. Let's start with V of B. So V of B, we're going to assume that all of the currents are exiting V of B, like we said, and we're going to assume that the exiting points are going to be positive. So plus I1 plus I2 plus I3 is equal to 0. Okay, we're just summing the currents to equal 0. But if we go and write out these equations using V is equal to IR, and we rearrange to say I is equal to V over R, then we can say V of B minus V of A over resistance 25. Here this is going to be V of start minus V of end over the resistance. So it's where the current starts and where it ends. Then we'll do the same thing for I2. I2 is going to be V of B minus V of C over R10. And then I of 3 is going to be V of B minus, what did we miss? Well, we forgot to put a ground. We need a reference point. So V of G over R50, and that'll be equal to 0. Okay, so let's go and go in here and write some of this out. This will be, if we were to multiply by the common denominator of 50, then we would end up with 2 V of B minus V of A plus 5 V of B minus V of C plus V of B minus V of G. That'll be equal to 0. Okay, if we go simplify that out a little bit more, 2VB minus 2VA plus 5VB minus 5V of C plus V of B is equal to 0. One more time, looks like we have 8V of B minus 5V of C, which is equal to, I forgot to add one part, minus 2V of A is equal to 0. And so you'll think like, well, we have 3 unknowns. It's kind of a lot for one equation. Well, let's go take a look at what we do know here. If we go up here, and we know V of G is 0, so everything along this wire also has to be 0. up until we reach this battery. And when we go through this battery, we'll pick up 75 volts, and we'll have 75, and then we're at V of A, and V of A is 75 volts. So we know V of A. So V of A is equal to 75 volts. So let's go down here and replace that. We can get 8V of B minus 5V of C is equal to 2V of A, which is equal to 2 times 75, which is 150 volts. So that's our first equation. All right, let's take a look at V of C. We're going to see if we can squeeze this in on the right here. So V of C, same concept. We're going to do now I5 is going that way, I4 is going that way, and then I2 is going that way. So I can do I5 plus I2 plus I4 is equal to 0. And then same as before, we'll just replace it with this bad boy here. So I5 is going to be V of C minus V of G over R25. We're crossing over the 25 ohm resistor. Plus I of 2 is going to be V of C minus V of B over our 10 ohm resistor. And then our I4 is going to be V of C minus V of A over our 100 ohm resistor, and that'll be equal to 0. Okay, and if we come in here and we'll multiply by our common factor of 100, we will get 4 V of C minus V of G plus 10 V of C minus V of B plus V of C minus V of A, and that'll be equal to 0. We go ahead and factor all of this out. Okay. Now we just need to combine like terms, and it looks like we have minus 10 V of B, 15 V of C, and then we have minus V of A is equal to 0. But we know V of A, so we can do negative 10 V of B plus 15 V of C is equal to V of A, which is just 75. All right, and that's our equation 2. So now we just need to solve this system of equations. And it's up to you which method you want to use. You can do plug and chug, or you can do, you know, Cramer's rule. Plug and chug, I feel, is pretty straightforward. So I'm just going to do Cramer's rule for everyone real quick. So I'll come over here and write 8V of B minus 5V of C is equal to 150. And then minus 10V of B plus 15V of C is equal to 75. Okay. Equations 1 and 2. So if we wanted to go and write these in matrix form, we can say 8, negative 5, minus 10, 15, do V of B, V of C, and then this will be 150 and then 75. All right. So now what we'll do is, so these are our coefficients, these are our unknowns, and then these are our constants or knowns. So what we'll do is every time we want to solve for an unknown, we'll just replace it with that column with the constant. So this is the V of B column, this is the V of C column. So if we want to solve for V of B, let's say, we will do the determinant of, remember this is the V of B column, and we're going to replace it with a constant. So 150 over 75, V of C column, which was -5 and 15, over the determinant of the coefficient, so 8 minus 5 over -10, 15. So this will give us 150 times 15 minus -5 times 75. Remember, the determinant of a matrix A, B, C, and D is just AB minus CD. That is not right. Don't believe that. It is AD minus BC. Then down here in the bottom, 8 times 15 minus -5 times -10. And I'll be right back with the math. 15. This will be 2,625 over yeah, there we go, 70. All right. And then this would just give us 2,625 divided by 70, 37.5 volts for V of B. Okay, and at this point you have the option of just going and plugging that into one of those two equations. Well, we're just going to continue on with Cramer's rule. So if we did V of C again, so determinant of, now this would be 8 minus 10 over 150, 75, determinant of 8 minus 10 over -5 over 15. Okay. This would be 8 times 75 minus 150 times -10 over, and we already found actually what the determinant is. It's the same in the denominator, so it's just over 70. So this would give us 2,100 over 70, which will just give us 30 volts for V of C. Okay, so let's just go up here and we're going to start dropping these bad boys in. So V of B, we said was 37.5 volts. V of C is equal to 30 volts. Okay, so that's all of our nodes. Now to find all these current values. All the current values are going to be just found using V is equal to IR. So V is equal to IR. Therefore, I is equal to V over R. And of course, this is going to be V of start minus V of end over the resistance. And forgive me, I'm going to have to scroll back and forth for these, but let me see if I can do this. Okay. Well, I'm just gonna come do it up here. How about that? All right. So if we look at I1, so I1 is gonna be equal to V of A minus V of B over R25, which will just give us V of A. So it was 75. V of B we found was 37.5 volts. R25, so that would give us 1.5 amps for I1. Then for I2, that would be V of B minus V of C over R10. So 37.5 minus 30 volts over 10 ohms would give us 0.75 amps for I2. I of 3 will be equal to V of B minus V of G over R50. So this will be 37.5 minus 0 volts over 50. That should give us 0.75 amps for I3. I4 is equal to V of A minus V of C over R100, which is 75 minus 30 volts over 100. Which gives us 0.45 amps for I4. And then finally, I5 gives us V of C minus V of G over R25. So 30 minus 0 volts over 25 will give us 1.2 amps for I of 5. All right, so there are all of our values. This was a rather extensive problem, but I just thought it went over a lot of very important concepts and was pretty in depth. So you should be able to get some good practice with this. If you can do this one, I feel like you can do some other problems of this caliber pretty easily. All right, well, thank you for watching this video and stay safe.